Okay, I'm going to run through the calculations for the stoichiometry lab. I'm going to use a different reaction than we used in class. This is the one from the airbag video. And I'm going to pretend that I'm filling the same plastic baggie with this reaction. So I want to fill it with the nitrogen gas we have here. So first thing we should do is we should find the volume that we need to fill up the bag. Many of you did this by filling with water and pouring it into a graduated cylinder and recording the measurements. And got a volume of around 1.2 liters. So we're going to use that number. We already know R. I wrote this on the board. 0.0881 liters times atmospheres over moles times Kelvin. The pressure of the room was 1 atmosphere. We assumed it to be 1 atmosphere. We need to find N. And we'll assume the temperature of the room was 298 Kelvin, which we got by reading the thermometer in the room and converting it to Kelvin. All this, we will use PV equals nRT to calculate our moles of nitrogen needed to fill the bag. So I'll rearrange this equation here, divide both sides by RT. Then we'll plug in these numbers into this equation here. Make sure our units cancel. Atmosphere on the bottom, atmosphere on the top, liter on bottom, Kelvin on bottom. Kelvin, remember this would technically be on top because you're dividing, because it's on the bottom of the bottom. Just cancel. And that leaves us with the unit of moles, which is good because that's what we were trying to find. Plug this into the calculator here. Yeah, approximately 0.0490 moles. And remember, this is moles of our gas needed to fill the bag, so it's moles of N2. Okay, but remember, we needed to fill our baggies with the required reagents. So we got to find out how many of a measurable unit we need. To start with that, we need to convert moles of N2 to moles of each reagent. In this case, there's only one reagent, and it is a solid. So we know our moles of N2 required. Then we can use our mole ratio here. So how many moles of N2 do we have in our equation? 3 moles of N2. 3 moles of N2 created. We need 2 moles of NaN3S. Moles of N2 cancels. We get 0.0323 moles NaN3. And then since this is a solid, we'll use our molar mass to convert into, into grams. If we had an aqueous solution, remember we'd use the molarity given and plug it into the equation. Molarity equals moles over volume. You plug in your moles. You're plugging your moles here. You plug in the molarity you're given here. And then you'd solve for the volume. And then that would be the volume you have to measure out for this. But that is only for aqueous solutions. So for this problem, we won't need that. We are going to go ahead and continue with our moles. So we want grams per moles. Okay, for every 1 mole of NaN3, we would look at our periodic table and we'd add the number for sodium plus the molar mass of nitrogen times 3. That will get us an approximate molar mass of 65.01 grams NaN. Then we calculate this. .13 grams NaN3. So we go to our scale and weigh this out, and this is how much of the solid we would need to fill the baggie. Hope this helps.